Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about critical values. So Mr. Barnes is interested in estimating the mean ski race time for a certain course for all high school skiers in Idaho. He plans to take a sample of 50 students and construct a 95% confidence interval. What T-star critical value should he use to construct the confidence interval? Well, to answer this question, we're going to look at the T distribution. You'll recall from our discussions in class that the T distribution is an estimate of the Z standardized normal distribution. That's a little more conservative because we're not confident in the sample standard deviation. So if we're looking for the middle 95% of the distribution here, 95% there in the middle, then we have to think about how much is in each tail. Well, we would take our confidence level and subtract it from 100% or 1, so 0.95 starts from 1 is 0.05. So there's 5% outside this middle 95%. And since there's two tails, we would then divide that by 2. And if we do that, we get 0.025. We're going to need that number here in a second to find our T star. We also need to note that our sample size is 50. So let's jog over to the calculator and see how we can find this T star. All right, from the calculator, what we're going to be doing here is we're going to go to our distributions menu. And if we were finding a Z star, we would use inv-norm. But since we're finding a T star, we're going to go down one more to inv-T. If we hit enter, it asks for several things. Area is not the area in the middle, so we can't put in 95%. It is the area in the tail. So we calculated that to be 0.025. And degrees of freedom is 1 less than the sample size. So we had a sample size of 50. We're going to use a degrees of freedom of 49. And we're going to hit paste and enter. And we get a T star of 2.0095. We can ignore the negative because that's part of the confidence interval formula, is that plus or minus. So here 2.0095 would be our T star. A second scenario here is, what if Mr. Barnes is looking at the same scenario? However, he wants to take a sample of 25 students instead of 95. Now, what would the critical T value look like at T star? Well, since the confidence level has not changed, we're still going to have the same area in the tail that we calculated for that original problem. What would change is our degrees of freedom, because degrees of freedom is based on sample size. Now, back at the calculator, we can follow the same steps we did before. We're finding a T star, so we're going to go to inv-T. We're going to leave the area the same. However, if we go down here, since our sample size was 25, our degrees of freedom is now 24. We're going to paste that and hit enter again. And you can see that our T star changed just a little bit. It got a little bit larger. Because we have a smaller sample size, we are less confident in our sample standard deviation. So we put a little more conservative value on this T star. To demonstrate the effect of sample size on our T star, you'll see here that for our sample size of 50, we had 2.095 for our T star. When we decrease the sample size to 25, you can see, as we just calculated a second ago, that it got a little bit larger, a little more conservative, because the sample size is smaller. We're less confident in that sample standard deviation. If our sample size got even smaller to a sample size of 10, then our T star would be even wider because we have to be even more conservative. You can see it went up quite a bit there. Now, comparatively, if we increased our sample size quite a bit, our T star would approach that 1.96. That was the same as our Z star for a 95% confidence interval. Thank you for joining us. I'll leave you with this quote by John F. Kennedy. Have a great day.